Okay, so we're going to take a quick look at modular synthesizers then. I've mocked up a modular synthesizer in this package called VCV Rack, which emulates a modular synthesizer, a typical modern Euro Rack modular synthesizer. So we'll start with the basic modules that we're going to look at building as part of this set of videos on building your own modular synthesizer. And we will build these modules and slowly build up patches, different patches using these modules. So we will look at voltage controlled oscillators, which is this first module here. That essentially is the bare bones of creating a sound. So any sound is just a vibration in the air, and that vibration in the air comes from a loudspeaker or a driver that drives the air, turns the electronic oscillations in the circuit, so the electrons moving around a conductor back and forth in an oscillation, and they turn that electronic oscillation into a movement in a diaphragm, the driver of or speaker, which then drives the air as a pressure wave at an oscillating frequency, and then that's the air pressure that your eardrum picks up and hears as sound. The frequency just tells you how frequently that vibrates. So frequency is just the amount or the regularity with which something happens. So if you say buses are frequent and they come once an hour, that would have a frequency of 1 per hour. If they came twice an hour, that would have a frequency of 2 per hour. For sound, we're looking at several times a second, and for the lowest notes that we hear, we get excuse me, an oscillation of down to about 20 times a second, or 20 hertz, and that gives us the low notes that we hear as a pressure wave, right the way up to, if you've got young ears and you haven't damaged them by listening to too loud music, you can hear very high pitches up to maybe 20 kilohertz. So a kilohertz is 1,000 cycles per second. So 20 kilohertz, 20,000 cycles per second are the very high frequencies that the human ear can just about hear. If you've, as I say, if you've got young ears, as you get older, then you lose that ability. So the range is roughly 20 hertz up to maybe 20 kilohertz. So our voltage controlled oscillator then is the module that produces that vibrating frequency. If you can see this light here, or this simulated light, this is a digital simulation of an analog synthesizer. That frequency increases as we turn this knob up, so it gives us the lower and higher notes. But at this point in time, that's just an oscillation of electrons in a circuit, so electrons moving around a series of conductors within this module, and we need to transfer that into sound. And we have our audio device here, which is an amplifier and a speaker, and we take an output from this voltage controlled oscillator, which is our sine wave oscillation. There are various different wave functions that we can get out of this voltage controlled oscillator, and we'll talk about those in detail later. But we've got a sine wave, triangle wave, a sawtooth wave, and a square wave. So if we take the sine wave out and patch that into our amplifier, we hear that as a note. Okay, and that note, let's turn that up a little bit, is oscillating at a frequency, so that in the actual module that we will build, that will turn the electrons oscillating around the circuit into sound waves through an audio amplifier and a speaker, and we'll come on to talk a bit more in detail of those. But the voltage controlled oscillator, if we vary the voltage using this knob here, then that changes the frequency. So as we turn it down, we get the lower notes right the way up to the higher notes. So that is the basis of our synthesized sound. So we've taken electrons flowing around this voltage controlled oscillator, taken them into an audio device, which is just an amplifier and a speaker, and that produces the sound that we hear. And that is the fundamental basis of what we're going to look at in these modules for our modular synthesizer. So we'll probably have a couple of voltage controlled oscillators. We will look at a low frequency oscillator, or an LFO, and that does the same thing as the voltage controlled oscillator, but it works at lower frequencies. So if you look at this frequency here, these are sub audio, so they're too lower frequency to be heard in audio, but we will see how they're useful for doing various things when we patch them in to other pieces of equipment. We will then look at filters, and filters subtract certain elements of the sound that we create with the voltage controlled oscillators, and we'll build one of those and talk about the details of that and how to patch those together. Then we'll look at something called envelope generators, ADSR. It stands for attack, decay, sustain and release. So attack, decay, sustain and release, and that is something that shapes the envelope, what we call the envelope. We'll go into a bit of detail as to what that means, again, to change the sound. We'll take various sounds from various different modules and we'll need to mix them together. So we will design and build a mixer, where in this case this mixer takes 4 inputs and allows those sounds to be blended together at different attenuation or different volumes, if you like, and then a master volume to control the sound coming out. And that allows us to mix various sounds from various modules together in a controlled way. We'll also look at a couple of different input devices. One will be a MIDI keyboard, standard MIDI keyboard, which controls the frequency at which our oscillators operate to give us different notes. So as we press the different keys on the keyboard, that will control our notes. Or we will look at this module here, a sequencer, and that sequencer produces a sequence of different notes. So we can play, in this case, up to 8 different notes in sequence, and they will all have their own different voltages which feed into our voltage controlled oscillator and change the note that we hear in a sequence. The other modules that I've got here are just to demonstrate how the sound looks, or it's a tool for looking at the sound in a visual representation of the audio, an oscilloscope or scope, and I've got 2 of them here just to illustrate those. We won't be building our scopes as a module, but we will look at how to build a simple oscilloscope for our actual real life modular synthesizer that we go on to build. Okay, next time we will look at our first simple patch.